So this video is the last video for Unit 1, and it's on the intermediate value theorem. The intermediate value theorem is used so much for justification for things. The people call it the IVT. You are welcome to refer to it as the IVT. You don't ever have to write it out. So you can always call it the IVT. But if you say intermediate value theorem, I think it kind of helps you remember what it is. All right, so here we go. Continuity of a function will prove to be an important characteristic in many theorems for our course. In order for theorems to be properly applied, we need to meet certain conditions. Namely, the if part, which is called the hypothesis, must be satisfied before we can apply the then part, which is the conclusion. In this lesson, we will explore our first existence theorem. Existence theorems always allow us to draw conclusions about a function's behavior on an interval without precisely locating that behavior. So we're going to talk about the intermediate value theorem, which is the IVT. Okay, the big idea says that the IVT says that a continuous function on an interval cannot skip values. Okay, so let's chew on that for just a second. That if I'm a continuous function, then I cannot skip values. All right, here's my example. Your height over the course of your life is a continuous function. It is a measurable continuous function. Here's why. At some point, you were 2 feet tall. At some point in your life, you were 2 feet tall. Now you are 5 foot something or 6 foot something. So the IVT says that at some point between whenever you were 2 feet tall and now, you were every height value in between 2 feet and however tall you are now. Let's see. Let's make this a little bit more concrete. And I don't know. Let's say at 2 years old, you are 2 feet tall. And at 17 years old, you are 6 feet tall. So what this means is that between 2 years and 17 years, the IVT will guarantee that you were every height in between 2 feet and 6 feet. No values were skipped because height is a continuous function. You could not have gone from 2 feet to 6 feet without being every single height in between. It cannot skip y values. Okay, so using if-then statements. If a function, y equals f of x, is continuous on a closed interval a to b, then f of x takes on every value between f of a and f of b on that interval. Okay, let's break this down just a little bit. If f of x is continuous on a closed interval a to b, now these are your x values. So I'm continuous on the closed interval. Let's go 2 to 17, and we're talking about how old you are. Then the y's take on every value between the y value at point A, which is 2 feet, and the y value at point B, which is 6 feet. So again, remember that f of something is a y value. So one more time, if a function f of x is continuous on the closed interval from here to here, from 2 years old to 17 years old, x values, then the y value, f of x, takes on every value in between f of a, how tall you are at 2 years old, and f of b, how tall you are at 17 years old. So your every value in between. It's called the intermediate value theorem. You have to be every value in between the output for A and the output for B. Okay, another approach. Said in a different fashion. If we know a y value, say y equals k, that resides between the two endpoints of f of A and f of B, again, both y values, then we are guaranteed at least one x value, let's call that C, between the endpoints that generates that y value such that f of C equals k. Makes perfect sense. Okay, let's look at this. So let's talk about these A's and B's and F ofs and K's and C's and all that stuff. Okay, so here we go. Here's A. Here's F of A. Remember, this is just a y value. F of A is just a y value. A is an x value because A is the input and F of is the output. Okay, so let's say I have a point right here because that would be A, the x value, and this would be F of A, the y value. All right, now I have B. Okay, so let's say F of B is down here. Okay, now what this says is that there's an x value, x equals C, between the endpoints. Okay, so that means it's between A and B. So I've got a C somewhere in here. Could be anywhere in between A and B. Okay. It says that you have a y value, we're going to call him K, that resides between the two endpoints of f of A and f of B. So I'm saying that I guarantee that C is somewhere from here to here, guaranteed. So could be here, could be here, could be here. But I can't, so hold on, he could do that, he could do that, and he could do that. So C is this guy, and f of C could be any of these y values as long as the y values are in between the y values of the endpoints. Here's what the intermediate value does not say. It does not guarantee that there is a y value above f of A. The function does not have to do that. It could, but it doesn't have to. Okay? But you guys see, you can see, let me change colors, that all of the y values in between these two y values are guaranteed because look, here they are. So to get from here to here, I have to go through all these y values. That's what it's saying. I could go above and then come down, but then again, I'm going to hit all those y values. This thick part is the guarantee. This is a maybe. That's the IVT doesn't touch that. So the IVT says that for some C that's in between A and B, so that there exists a K that's between f of A and f of B. Again, these are x values and these are y values. So C is the x value and K is the y value. And it doesn't have to be headed downhill. F of A could be down here and f of B could be way up here. Okay, so I have to get from point A to point B. And I can go all kinds of crazy ways to get there. But what the IVT guarantees is that there is some C in between A and B such that f of C is between f of A and f of B. somewhere in between A and B, you have to go through those y values. An important outcome of the IVT is that it can be helpful in finding zeros of a continuous function. If one of your y values is negative and one of your y values is positive, then I guarantee you one of the y values in between is going to be 0 because it has to cross the x-axis at some point. So, and it doesn't matter which one comes first. It could be negative to positive, or it could be positive to negative. It doesn't matter. But if one of your y values is positive and one of your y values is negative, then I guarantee that there's a 0 in between those two. IVT really comes in handy for that. Okay, does the IVT apply on the specified intervals for the piecewise functions shown below? Be sure to explain completely. Okay, so I have a function. I notice that it's not continuous for the whole time. So it says, is there a value x equals c on the interval -2 to 5 such that f of c equals 1? Okay, so here's what it's asking. Is there an x value? I don't know what it is. I'm going to let it be c. On the interval -2 to 5. Okay, so let's look. -2 to 5. Such that f of c equals 1. Now remember, f of c is y equals 1. So is there a value of x equals c on the interval from -2 to 5 such that f of c equals 1? Well, let's look. Here's f of c equals 1 would be right there. So the c value that makes that happen would be about 3.5. So it's not asking for what the value is, but I can say yes. Yes, c exists from -2 to 5. I can see it on that graph. C exists. There is a c such that f of c equals 1. Absolutely. I can see it. Oh, it happens over here too. At -2, I don't know, 0.6. Okay. Now let's look at part B. Does the IVT guarantee a value of c on the interval from -2 to 5 such that f of c equals 1? Justify your answer. And the answer is absolutely not. No, the IVT will not touch this interval of this graph. And the reason why? F of x is not continuous on -2 to 5. IVT won't touch it. Now, I can look at it with my eyeballs, and I can say, yes, I can see it. It happens at x equals 3.5 and x equals -2.5. But the IVT will not touch this graph because it's not continuous. So that is the #1 rule for IVT. If you're not continuous, the IVT will not go near it. Okay. So you've got to understand the difference between logic and what you can see with your eyeballs and what this existence theorem will guarantee, will prove. All right, is there a value of x equals c on the interval 1 to 6 such that g of c equals 3? G of c equals 3 from 1 to 6. So my interval's from 1 to 6. So from here to here, is there a y value such that I'm going to get a 3? No. Not on the interval from 1 to 6. There is no g of c equals 3 on 1 to 6. There is no c value so that g of c equals 3 on 1 to 6. Again, that's logic. I can see it with my eyeballs. Does the IVT guarantee a value of c on the interval 1 to 6 such that g of c equals 3? Okay, so the first thing you're thinking is continuity. So I need to talk about, is g of x continuous on 1 to 6? And the answer there is that's true. So that's not our reason. From 1 to 6, he is continuous. However, what is f of 1 and what is f of 6? Well, f of 1 is 1.5, and f of 6 is -1. Now, remember that the IVT says that if C is between A and B, then I guarantee you there's a Y value K that's in between f of A and f of B. Well, that's where this one falls short, because f of 1 is 1.5 and f of 6 is a -1. Well, that's my K value. That's my output, my 3. So I can say that f of B is less than, let me see, think of the best way to say this. What I want to be able to say for it to be true, especially for this one, because I have values, I want to be able to say, now he's the smaller one, f of 6 is less than or equal to 3 is less than or equal to f of 1. That's if it's true. That's saying here's a y value, there's the y value I'm interested in, and there's the other y value, and it falls in between. But this is a false statement because that's not true. Not true. I think that says true. So continuous, yes, but the output, 3, is not in between the two y values of my interval. So it doesn't guarantee it. It won't touch it. Okay, so what are the 3 conditions necessary to apply the IVT? First of all, f of x must be continuous on the closed interval a to b. Has to be closed. I know when we've talked about continuity, it's always been on an open interval, but for the IVT, it is closed. Okay, the other thing is your 2 endpoints have to be different. Your 2 y values. So f of A cannot equal f of B. You can't tell me at 2 years old you were 2 feet tall and at 17 years old you were 2 feet tall. The outputs can't be the same because I can't guarantee that you did anything in between 2 feet tall. I can't say you went up to 6 feet and then came back down to 2 feet. IVT doesn't guarantee that. So those 2 y values have to be different. And then the other thing is that f of c must be between f of a and f of b. And that's what we were talking about this last problem, that f of a or the other point could be smaller. It doesn't matter. It just has to be between them. So again, these are talking about y values, and the c has to be in that interval. So if I'm talking about from 2 to 4, and I'm interested in x equals 7, IVT won't touch that. The x has to be in between the a's and b's, and the y value, the output, which is normally a k, has to be between the other 2 outputs. Okay. So now let's apply. Let's see what it's going to look like. Apply the IVT, if possible, on closed interval 0 to 5, so that f of c equals 1 for the function that's parabola. Okay, apply the IVT on 0 to 5. Well, I know that this is a parabola. It's very well behaved, that it is absolutely continuous from 0 to 5. So let's start there. Step number 1, f of x is continuous from 0 to 5. Check. Technically, it's continuous from negative infinity to positive infinity, but all we need is for it to be continuous from 0 to 5. Closed interval. Okay, step number 2, I need to find the outputs. So I need to find f of 0 and I need to find f of 5. I need to make sure that they are not the same. So when I plug in a 0, I'm going to get a negative 1. When I plug in a 5, I'm going to get 25 plus 5, which is 30 minus 1, 29. Okay, so I have just proven that f of 0 does not equal f of 5. So guys, what we're saying is that for all the x's in between here, they will at some point take on the y's that are in between the negative 1 to 29, that every single y value will get used in the life of that graph from 0 to 5. That every single y value from negative 1 to 29 will get used because I'm continuous. I have to get from a negative 1 to a 29 in the span of 0 to 5. Now, they have told me this. They're looking for C. So ladies and gentlemen, I'm looking for the X value that will produce that Y value. So by the IVT, there exists, remember this is just an existence theorem. So you are just stating, yes, it exists. There exists a value C. Now remember, that is an X value, where f of c equals 1. That is a y value. Since let's do this. Let's say since f of 0 is less than 1 is less than f of 5. Okay, take a second, wrap your brain around that. I have to be comparing either all x's or all y's. So first of all, decide if these are x's or y's that I've just written. And these are the y values. F of 0 is a y value. 0 is the x value, but f of 0 is the y value. This 1 is a y value. Well, technically, what is f of 0? It's negative 1. And what is f of 5? It's 29. So is this a true statement? Are they asking me for a y value that's within my range of y values? Absolutely true. And that's what this is saying. This is saying that it does exist. F of c equals 1 exists. I don't know where c is. My job is not to find the x in this particular problem. Well, my job is to state that it exists. And I'm saying it does exist. Number 1, it's continuous. Number 2, the two endpoints are not the same. And then I conclude, by the IVT, there exists a value c where f of that x value could equal a 1 because 1 is in between the two y values of the endpoints. Use the intermediate value theorem to show that that's a cubic function, very well behaved, has a 0 in the interval 0 to 1. Okay? So has a 0 means that it crosses the x-axis. So number 1, I'm going to state that f of x is continuous. It's cubic. They're very well behaved. True. Number 2, I need to find f of 0 and f of 1. But because it's looking for has a 0, I'm not just looking to make sure these two are different. I'm looking to see that they are different signs, because that's what's going to make it cross the x-axis. So f of 0 is a -1. F of 1, 1, 3, 2. Okay, so I have opposite signs. So number 3, by the powers of the IVT, there must exist a value C where f of C equals 0. Since f of 0, that's my smaller one, there you go. Since 0 is in between those two outputs. Now remember, this one could have been, like, let's say this one wasn't a -1, let's say it was a 5, and let's say he was a -3. So then when I write this, I'm going to write my f of 1 first because he's the smaller guy, and f of 0 is going to go over here. So these things down here are based on the output values, not the fact that 0 is less than 1, but the fact that -1 is less than 2. Okay, here's what it looks like in a word problem. A car travels straight, let's try it again. A car travels on a straight track. During the time interval, 0 to 60 seconds, the car's velocity measured in feet per second is a continuous function. That's important. The table shows the selected values of the function. For 0 to 60, must there be a time where the velocity of that time equals -5? Justify your answer. So I am going to assume that it would happen here, because that's where -5 would be. That's the output. So I'm going to say that the time is somewhere between a 35 to a 50 seconds. Now, could it happen in between 25 and 30 seconds? Absolutely. You have no idea what it's doing in here. You don't know that it's just going from -20 to a -14 velocity in feet per second. It could be going from -20 to +8 and then back down to -14. You don't know. This is a big gap. That's a big gap of time. That's 5 seconds. It could do tons of stuff. So I'm not trying to project or guess what's happening on things that I cannot prove. Okay? So I know that I have to go past a -5 to go from -10 to 0. It would have to cross at -5 because it's continuous. And guys, that's all the IVT is. If I'm continuous and I know at 35 seconds I'm at -10 and at 50 seconds I'm at 0, then I know somewhere in between 35 and 50 seconds my velocity hit -5 feet per second. So answer to A is yes. Justify my answer. Number 1, v of t is a continuous function. Set it. Set it in the problem. Number 2, I'm going to find v of 35, and that's a -10, and v of 50, that's a 0. They are not the same. So number 3, by the powers of the IVT, since I know that, let's see, how do I want to write this? I'm going to go, you could do it this way. You could say -10 is less than -5 is less than 0. Or you could say f of 35 is less than -5 is less than f of 50. Either one of those two is fine. Make sure you're okay with both of them. So since that's true, the IVT guarantees a time t, where v of t would equal 5 on the x is 35 to 50. Negative 5, sorry. V of t is negative 5 on the x's 35 to 50, or on time, 35 to 50 seconds. Okay. Number 6. Let g of x be a continuous function. Selected values of y equals g of x. Now listen, when they give you selected values, that always gets you into trouble because these are selected values. You don't know what they do in between these numbers. These are just selected values. I do know that I'm continuous though. For what value of k will the equation g of x equal a 3/4 have at least two solutions on the closed interval 2 to 8? All right, closed interval 2 to 8, that captures the whole chart table. And I want, for what value of k will I get have at least two solutions on the closed interval 2 to 8. G of x. I don't like this one. Let's hold off on him. Yeah, let's hold off on him. Definitely. Yep. Let's hold off on him. Let's go to 7. Oh yeah. Yes, definitely. Much better. Here we go. So I have a piecewise function. I am quadratic for one value, x equals 5. And I am a constant 6 from 5 to 10. I need, does an IVT guarantee a y value k on 5 to 10 such that f of 5 is less than f of k is less than f of 10? Justify your answer. Okay, so number 1, am I continuous? Well, I don't know. I mean, I know a parabola is continuous, and I know the 6 is a continuous line, but I don't know if the function overall is continuous. So what I need to do is I need to find the limit. I need to find the limit as x approaches 5. Yeah, because that's the break. From the right, and the limit as x approaches 5 from the left. So the limit as x approaches 5, if I plug a 5 in there, 5 minus 3 is 2, 2 squared is 4. So at 5, the parabola is at 4, and then after 5, the function's at 6, all the way to 10. So no, this guy's not continuous, because the limit as x approaches 5 of f of x does not exist. We are not continuous. Heck no, does not apply. So I would say IVT does not apply because f of x is not continuous. That's it. That's all you have to say. That limit does not exist. All right, number 8. The functions f and g are both continuous. Lovely. For all real numbers, the table below gives values of the functions that selected values of x. Okay, so be suspicious. The function h is given by h of x equals g of f of x plus 2. Explain that why there must be some value of w in between 1 and 6 such that h of w equals 0. Well, this just sounds like loads of fun. Let's highlight the important stuff. We need him. I need that, and I'm looking for that. Now, h of w equals 0. That makes me think I need an endpoint to be positive and one endpoint to be negative. So the first thing I'm going to do is, number one, I'm going to state that f and g are both positive. I mean, not positive, continuous. Are continuous. Therefore, h of x is continuous because h of x is made up of g of x and f of x. Okay, number two. I need to find the y values of my endpoints. So I need to find h of 1. Okay, h of 1 is g of f of 1 plus 2. Okay, let's find f of 1. F of 1 is 2. So now I need g of 2 plus 2. G of 2 is negative 12. So I hereby declare that h of 1 is a negative 10. Okay, now I'm going to find h of 6. All right, so what I want you to do, I want you to pause the video and go find it. Just like I did for the h of 1. You go find h of 6. When you got it, hit play. So g of f of 6 plus 2. F of 6 is 8. G of 8 is 28. Okay, so I have found them. They are not the same, and one is positive and one is negative. Okay, so here we go. By the IVT, there exists a value W where h of W equals 0 since, I'm going to use the word since instead of because. Since, all right, now which one's my smaller one? H of 1 is my smaller one. There you go. Since this output is in between the other two outputs. And then I'm just going to put on my interval. On the interval 1 to 6. And that's an open interval because that's how it gave it to me. Okay, I know this is complicated, but the more you handle it, mess with it, write about it, when the writing is a pain in the butt, the better you'll get. But remember, the IVT is just an existence theorem. Does it exist? And think about the conditions that you have to meet in order to get there.